This strange contraption changed the world. Little more than a wooden ramp and a bucket of water, it shook the foundations of the Catholic Church and created the Age of Reason. I went on a journey to find out how.
Apparently, what does it apparently mean? Okay, drop 'em!
I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago.
Here in my garden, young Kieran and I are doing an experiment that the 9-year-old Galileo helped his father Vincenzio do in the Italian city of Pisa in the 1570s.
Right, okay, plug it. Okay, another brick.
Vincenzio was a gifted musician who wanted to show that the accepted theories about tuning were misguided. He designed simple experiments with lute strings and weights to prove this.
Bang! And again.
Also, Vincenzio got into fight after fight with his musical patrons. And although they were men of influence and paid his salary, what was important to Vincenzio was that they were wrong and they needed to be told so. So if Galileo got one message, it was this: just because someone has power, they're not necessarily right. When Galileo was 19, his impoverished father sent him off to Pisa University to study medicine. He hoped this would guarantee his son a well-paid career. But Galileo hated medicine, and he soon gave up on it when he encountered the geometry of the Greek mathematician Euclid. He became convinced that its triangles, circles, and geometric figures were the alphabet in which the grand book of the universe is written. Galileo's first realization that nature obeys mathematical principles came as he watched a pendulum-like lamp swinging back and forth in Pisa Cathedral. He timed it using his pulse. He counted the number of heartbeats during each swing of the pendulum and noticed something very, very peculiar. Today we call it isochronism. Professor Tom Settle from the History of Science Museum in Florence joined me in my shed to talk me through the phenomenon the young Galileo had discovered. Tom, what actually is isochronism?
Isochronism means essentially same time. And in the case of the pendulums we have here, it means that if we take a pendulum and let it swing back and forth like that, the time that it takes to go from here to here is the same on a large excursion as the time on a smaller excursion to go from here to here.
So if I let them off like this, they're going to take roughly the same. They're going to take the same time.
They're going to, in principle, take exactly the same time.
It's extraordinary that no one had spotted this before, and without it, we'd never have had the pendulum clock. Galileo noticed this when he was how old? About 20?
About 20-ish. Yeah, 20 years old, give or take change.
Apparently, what does it apparently mean?
Galileo had charisma and soon attracted a circle of admirers. He made a living as a maths tutor to the sons of nobles, and in these years he developed a passion for wine, which he described as moisture held together by light. But his academic career was not going so well. In this room in Pisa University, he was always challenging his professors. They wanted him to learn the teachings of the Greek philosopher Aristotle without questioning them. But the more he examined Aristotle's ideas, the more Galileo thought they were hokum. For example, Aristotle refused to accept the idea that ice was lighter than water. He said that it floats because it can't part the water particles. So Galileo, who loved flouting Aristotelian physics, got himself immediately a bucket of water. He got himself a lump of ice. He pushed the ice to the bottom of the bucket of water, released it, and it floated up to the top. You see, says Galileo, it can part the water. Galileo left university without getting a degree. The Catholic Church decreed that disagreeing with Aristotle was heretical. This was the era of the fearsome Inquisition, a religious thought police who imprisoned, tortured, and even burned heretics alive. But this didn't stop Galileo. He now attacked an idea that was central to Aristotle's physics. Aristotle believed heavy things fall faster than light ones. On the face of it, Aristotle was right. A hammer, for instance, undeniably drops much faster than a feather. But Aristotle made no mention of the effect of the air, and this bothered Galileo. Galileo started doing experiments. He dropped objects of different weights, but of more similar shape than hammers and feathers. Over short distances, at least, the balls seemed to hit the ground together. But Galileo realized a man's height was too short a drop to be conclusive. Next to a Tuscan church tower, I joined Professor Settle to discover the next stage in Galileo's investigation.
Step by step, Galileo also began dropping things from high places, a high balcony or quite a high tower. There's a story that he did this from the Leaning Tower of Pisa. Yeah. We don't know whether that's actually true or not, but any high place will do.
Okay, well, we've got Geraldo up there standing in for Galileo's gopher.
Ready?
We ready?
Right.
Okay, drop 'em! Well, the heavy metal ball did drop before the lighter red cricket ball. About that much. It seems Aristotle's right. The heavy ball does fall more quickly. But Galileo felt, just as with the feather, air resistance was confusing things. Okay, drop 'em! Galileo's next step was to devise an historic experiment, one that would allow him to work out what really happens when things fall. It would make him the father of modern science.
Number 2 interval.
This simple arrangement created the method used in all scientific experiments. First, Galileo decided to roll the balls down a slope rather than drop them. This minimizes the effect of air resistance. Then he designed a brilliantly simple way of measuring time, a bucket of water with a plug hole and a measuring cylinder under it.
How?
What he did was roll the ball down the slope from the top, and when it reached the end, he'd stop his timer by cutting off the flow of water. So the amount of water collected represents the time the ball took to fall.
So he'd have done it like this, wouldn't he? He'd let that go and take his finger off at the same time.
Correct.
With this simple device, Galileo raised the stakes in his battle with Aristotle. According to Aristotle, a heavy ball rolls faster than a light one, so less water will be collected. According to Galileo, all balls will roll down the ramp in the same time, and so the water collected will be the same. The cricket ball is much lighter than the metal one. Let battle commence.
Beautiful sample there, Professor.
Galileo did this experiment over and over again, and no matter the weight of the ball, it always took the same time to roll down the slope.
In many ways, Galileo is the founder of the modern understanding of motion and mechanics and physics, with a set of apparently simple but very profound experiments. You can unlock the mysteries of mass, speed, acceleration, force. This is all Galileo's legacy.
Galileo showed that simply observing what we see on Earth can mislead, but experiment can reveal the truth.
I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects. And we thought that where would be a better place to confirm his findings than on the moon.
In 1971, when Apollo 15 went to the moon, the astronauts took a hammer and a feather and showed us what Galileo's scientific instinct had told him 3.5 centuries earlier.
They'll hit the ground at the same time. How about that?
Galileo realized he was onto a whole new way of understanding the universe. But when he extended his scientific investigations from the movement of earthly objects to the movement of heavenly ones, all hell would break loose. In the early 1600s, things were not going well for Galileo. Though he'd wangled a job as a maths teacher in Padua University, the pay was measly, and not enough to support his mistress, their 3 children, his wastrel brother, and pay his sister's dowry. Galileo was reduced to writing begging letters when news arrived that the telescope had just been invented in Holland. He immediately made one himself.
And he quickly marketed this instrument first as a military instrument. There are these letters reporting the story of Galileo taking the Venetian senators up to the bell tower, the St. Mark's bell tower.
Yeah.
So these elderly senators, going up the stairs so that Galileo could show them how far one could see ships at sea with the telescope. So initially, Galileo tried to market it as a military instrument to detect enemy ships from far away. And then he turned it to the sky.
In Galileo's day, most people believed the Earth was at the center of the universe, and that the sun, the moon, the planets, and the stars were unblemished spheres. Everything in the heavens revolved around the Earth. What Galileo saw with his telescope convinced him all this was wrong. Celestial objects were far from unblemished. The moon was rough and craggy. The sun had spots. And worse still, there were objects out there near the planet Jupiter that very definitely did not go round the Earth. Mario Biaggioli in the National Library in Florence. We're looking at Galileo's actual